All right, let's keep going. This is your Unit 3 test review. I'm hoping this video can cover pages 3 and 4. I guess we'll see how long this page takes us to get through. But let's start here with number 14. So here's yet another one where we need a second derivative, which of course starts with finding a first derivative. And I am going to need chain rule here. So chain rule is going to be used anytime you have like something inside of something else where the thing on the inside has its own derivative. It's not just an x, okay? Because if it was just an x, its derivative would be 1. But if it has some other derivative than 1, then we have to worry about chain rule, right? So when I'm writing out my first derivative here, I guess maybe I'll start this over here so I have room. My chain rule is going to start with the derivative of this piece on the inside. And what I want you to remember, well, first of all, that 1 doesn't matter, right? The 1 is going to have a derivative of 0. But this inside here is like a 1 over 20 times x. So the derivative of that is 1 over 20 times. Now I'm going to do my outside derivative, which is the power of 5. So that derivative is going to be a 5 times something to the 4th power, right? That's how you do a derivative of a 5th power. And on the inside of that is going to be exactly what's circled in the pink in the step before this. And I do think that I'm going to clean this up a little bit just because I know I have to take a second derivative. So the more I can simplify, the better. Really, the only thing I can see that I can simplify would be these. So if I made that a 5 over 20, 5 over 20 is the same as 1/4. 1 plus x over 20. And then to the 4th power. Okay, so now second derivative. Chain rule. Derivative of this. Now this is the same thing it was when we started, right? So it has the same derivative. It has that 1 over 20 as a derivative times. Now I'm doing the derivative of 1/4 something to the 4th power. So the 1/4 I know is going to stay. And then it'll be 4 times whatever to the 3rd power. And once again, my whatever is the thing circled in pink. So that actually has not changed since the beginning of the problem. And then just to clean this up a little, let's put all of this together. Okay, well, 4 times 1/4 really cancels itself out, right? And so I really just have this 1 over 20 times 1 plus x over 20 to the 3rd power. So now let's go back here and do my second derivative specifically at 40. So I'm going to have 1 over 20 times 1 plus 40 over 20 to the 3rd power. Well, that's 1 over 20 times 1 plus 2 to the 3rd power. That's 1 over 20 times 3 to the 3rd power is 27. And so I would probably just leave this as 27 over 20. And again, this is one that I could put into Desmos, right? I could type in f of x equals and then ask Desmos, hey, what is f double prime of 40? And it will tell me, okay? Your calculator is going to have a harder time doing the second derivatives. If this was a first derivative question, it could do that for you too. Okay. I got a lot of questions on number 15, specifically parts B and C, but let's blaze through A real quick. So it's telling us what our derivative should be. We just have to make sure we agree with that, okay? And it is a implicit differentiation. You've got x's and y's in there. So I'm going to start with the y squared. I know that's going to have a dy dx with it. Times the derivative of y squared, which is 2y, equals. The 2 is going to cancel out because its derivative is 0. Now I'm doing product rule with the xy. So derivative of x is 1 times y. So that's u prime v plus v prime gives me a dy dx times u, which is x. Okay. So I have to pull everything to one side, or pull all the dy dx's to one side. So I'm going to do this. I'm going to kind of condense some steps here because we've done a lot of these together, and I think you can follow me. I just want to take this thing and move it over here. So now the left side of my equation will look like this. dy dx. And then in parentheses, it'll have the 2y minus the x, right? If I pull that over to this side, and then it just equals y over here. And then your very last step would be to divide by that parenthesis, which would take you back to where we were over here, right? You'd have y over 2y minus x. So, I mean, if this was the AP test, I would certainly take the time to write out that last step. For the sake of space, I think you can make that jump, but that's what should happen there. Okay, so what I want you to notice here, it says find all the coordinates where the tangent line has a slope of 1/2. The tangent line slope, that is the derivative. Okay, so when you're looking at that and you're like, well, I don't know what to do with that. That's talking about a tangent line derivative, right? The tangent line slope is talking about a derivative, is what I should say there. So we have the derivative, right? We just found it. So my derivative is y over 2y minus x. And I want to somehow make this thing equal to 1/2. Now you might see what needs to happen right now. Like you might see mathematically, you know, something cancels out or whatever. What I would do if I had to solve this thing is I would cross multiply. So I would say y times 2 gives me a 2y. And 1 times 2y minus x gives me a 2y minus x. And what I hope you'll see now is those 2 y's on either side that I can cancel. So what I really have now is 0 equals negative x, which is the same thing as just saying x has to be 0. Okay, so that's great. What we just found out, what we just figured out here, this is telling us that anywhere x is 0, I'm going to have a slope of 1/2. The question is, when is that? When does x equal 0? Okay, and for that, I have to go back up here and use my original function. Okay, so I'm taking that x equals 0 and I'm plugging it into this. Y squared equals 2 plus x, which I'm going to make be a 0, and then times y. Okay, well, that makes this easy, right? This just goes away. So y squared equals 2, and then to solve that, I would take a square root. But of course, when I take a square root, I have a plus or minus. So to answer the question, if we want coordinates, we want to take these two things and pair them up. So I would say at 0, square root of 2, and at 0, negative square root of 2. This would be a really good one to check out on Desmo, so I'm going to do that really quickly here for you. Okay, so what I am doing is I am graphing not the derivative, but I'm graphing the original relation, which is this up here. So that is a y. Oops, I always forget. Takes a couple clicks to get back into the browser here. So y squared equals 2 plus xy. Y. There we go. Okay. And so what we are suggesting is that at the point 0, comma, square root of 2, and at the point 0, comma, negative square root of 2, that those slopes are equal to 1/2. And so take a look at your graph there. You've got a green dot and a blue dot. Maybe I can bold that up a little bit. There we go. Okay. Probably, I mean, we could go through the process of like writing tangent lines, right? But really what you're looking for here is you're trying to confirm that if I were to draw tangent lines, these would both have a slope of 1/2. So if I drew that line in there, and if I drew that line in there, and honestly, just the visual would be enough for me to say, you know what, those slopes look like they'd be the same. 1/2 seems reasonable. I mean, could I do like a up 1/2, up 1/2 and see how I'm doing there? Sure. I don't even think you have to work that hard. Okay. But what we're showing is that these are the places where this is happening, that I have a slope of 1/2. Okay, let's go on to that next part. Kind of continuing in the same fashion here. This says show that there are no points where the tangent line is horizontal. Okay, I really want us to think about that wording there. Okay, if the tangent line is horizontal, that means my slope is equal to 0. Which, in other words, my derivative is equal to 0, right? So I'm kind of approaching this the same way I did right here. This part is going to feel very much the same. I'm going to say I want y over 2y minus x. I want to know when will it equal 0. Okay, so remember, if you have a fraction that you're trying to make equal 0, I need the top to equal 0. And if you're not sure about that, right, this is like a 0 over 1. Or this number on the bottom, honestly, could be anything. Could be whatever you want. But the idea here is we want this top number to equal 0. So that's kind of what I'm starting with. I'm starting with I need y to equal 0. Kind of along the same lines of what we were just talking about, right? Is anywhere where y would equal 0, I am going to have a horizontal tangent line. So let's go find out when that happens, okay? And if you're thinking like, wait a second, this said to show that it doesn't happen, let's just see, right? So if I put that 0 in to my original relation, I have 0 squared equals 2 plus x times 0. Okay, so I get a big fat 0 over here. I get a 2 over here. The x times 0 goes away. And this is what I'm left with, 0 equals 2. That is not a thing, right? That can't happen. So what that's telling me is there is no point where this is true, okay? It is true mathematically that if y were ever equal to 0, I would have a horizontal tangent line. But if you think back to this graph, and honestly, we had this graph up here a second ago. If you look back at this graph, there is no place where we're going to have a horizontal tangent line because there is no place where y equals 0. This graph never touches right here, okay? So you can't have a horizontal tangent. Okay, get the back out of there. All right, let's keep going. Number 16. Okay, these are good ones. So trying to find a derivative here, right? Because what I really want here is I need to know, well, how do I find h prime of x? And I really encourage you to write it this way first. Well, if I'm having to take the derivative of this thing, that's going to involve chain rule. And so I'm going to start with this inside derivative, right? So I'm going to say that's g prime of x times, and then I'm going to go back to the outside and take the derivative, but it's not f prime of x, it's f prime of the thing in pink, right? Which is, oh, messing up my color system here. I said the thing in pink. The thing in pink was g of x. Okay, so now let's figure that out at 1. So h prime of 1 is going to be equal to g prime of x. Nope, just kidding. G prime of 1 times f prime, be careful here, of g of 1. Okay, want to make this super clear. This is not multiplication. We are not multiplying anything together. This is a composite. So this is saying do g of 1 first. Get that answer, plug it into f prime. So let's get g of 1 out of my table. I'm looking at just the regular g of x function at 1, and so that value is 2. So what I'm really doing is replacing this with a 2. And so now g prime of 1 is 8, and f prime of 2 is negative 2. So to answer this question, I would say this is 8 times negative 2. And so my final answer here would be negative 16. That's for that part A. Okay, so similar in the next one, right? Let's start with k prime of x, which is going to start with the inner piece, the f of x. So I'm going to start with f prime of x times. Now let's go to g prime, but it's not g prime of x. It's g prime of f of x. And let's do it at 1. So k prime of 1 means I need f prime of 1 times g prime, of f of 1. And first order of business is to figure out what the heck that f of 1 is. Okay, so in my f function, here's my f of 1, which is negative 6. So I'm now looking for f prime of 1. So f prime of 1 is this one right here. It's the 3 times g prime of negative 6. So, oh, you know what? I think this was the one I had you correct in class. I'm sorry about this. I didn't correct it here on my version. I told you to make this 6 be a positive 6, and it was for this right here. So this is, we're going to say, is a positive 6 because I can't find g prime of negative 6. But I can find g prime of positive 6, which is negative 1. And then 3 times negative 1 would be negative 3 as a final answer. Okay, one last one here, and this one has to do with inverses. Let me clear off my table over here because I've done a fair bit of scribbling. Okay. So when these functions are inverses, here's what I want you to realize. I'm asking you to find j prime of 8. So that means in the j function, I must have a point that is 8 comma something. And if j and f are inverses of each other, then f must have the coordinate something comma 8. Okay? Those 2 points correspond with each other as inverses. And so there's a relationship between their derivatives that we'll get to in a minute. But the problem is, I don't know anything about j. I only know about f. So I'm going to really have to focus on this point right here, which means I really need to know what this x value is, right? I need to know what this is. So the first question I'm asking myself is f of what gives me 8 as an answer? So let's look in our F column. Where do we see 8 as an output? I see it right here. So that is with a 3. Just filling in my value that I now know. And technically that means this is a 3 too, but that's not going to matter to us really. Okay, so now I have my point, right? What I want to work with is this 3. And I can find my derivative there. So I'm going to find f prime of 3. Okay, f prime of 3 is this 7 right here. So actually, I'm going to jump over here for a quick second and say that what we just figured out, I mean, I have it written here to the left, but we figured out that the derivative at this point is equal to 7. The thing is, I don't want the derivative at that point. I want the derivative at this point, okay? So what I really need here is j prime of 8. Well, the relationship between these two derivatives, like this answer that I'm looking for and this answer that I already have, is that they have to be reciprocals of each other if these two things are inverses. So if I know this one is 7, then I know the derivative that I'm looking for is 1/7. And that's it. That would be my final answer there. Okay, this video got pretty long. I'm closing in on 20 minutes here. So I do think I'll just stick with page 3 here, and we'll pick up with page 4 in another video.